Hello students, welcome back to the class. Students, today we will be studying the second part of this chapter, and in this we will be learning about the carbon monoxide, which is a gas, and we know its molecular formula is CO, which we already have read in the chapter hydrogen. In the manufacturing of hydrogen we use carbon monoxide, right? And its molecular weight is 28, and it is not normally present in the air like freely, but when we burn the products, when we burn the compounds which has a carbon in it, or when we burn the carbon, then it combines with the oxygen present in the air, and then it forms its oxide, that is carbon monoxide. And these automobiles, when the fuel burns in them, then what happens, the carbon monoxide is released into the air, and which it also causes the pollution. What are the properties of carbon monoxide? It is a colorless, odorless and tasteless gas, students, and its density is similar to the air, almost similar to the air, and it is slightly soluble in water. And when we you might have read, when we when we heat certain compounds, then they decompose into their constituents, but this carbon monoxide, it does not. Even on strong heating, it does not decompose. Students, this gas burns, that means it is a combustible gas, but it does not support burning. That is supporter of it is a combustible gas, but not a supporter of combustion. And in the air, when we burn this carbon monoxide, then it burns with a blue flame, and then it reacts with the oxygen present in the air, and then forms carbon dioxide. And students, it is very poisonous gas. And if we students, you might have read in your biology subject in class 6 that oxygen combines with the hemoglobin which is present in the blood, and then it forms a compound called oxyhemoglobin, and this oxyhemoglobin transports to the various parts of the body, and then it dissociates to release the oxygen. So what happens is that this carbon monoxide gas, it gets combined with the hemoglobin, and it forms carboxyhemoglobin. Now this carboxyhemoglobin, it is a stable compound. That means it does not dissociate very easily, and then it decreases the capacity of the hemoglobin to combine with the oxygen, any more oxygen, and reduces its capacity. And then what will happen, a person will not get the proper amount of, or the sufficient amount of oxygen, and will die. And this particular condition is known as asphyxia. And students, you might have heard many times that in the winter season, what do people do? They keep the burning coal in their room, and then they close the room, and then they sleep, and the next morning they are found dead. It is because the carbon monoxide has occupied all the area that is present in the air, present in the room, and the people sleeping there, they have inhaled that gas, and this gas, if it forms carboxyhemoglobin, a compound which is more stable in the blood, and then they die of asphyxia. Then standing in the closed garage with the engine of an automobile running. Students, as I have told you earlier, that when the automobiles, when we use fuels in them, then they releases carbon monoxide. So if we are standing somewhere where the engine is running, not necessarily garage or any room we are standing in, and if there is a car whose engine is running, and if we are standing there, then after some time we will lose our consciousness, and ultimately we will die. Now what are the remedies, or how we can prevent this carbon monoxide poisoning? So first of all, the person who has inhaled this carbon monoxide, it has to be taken outside where there is a free air, the fresh air is there, so that he or she can breathe properly. Other than that, students in class 7th, you have read about carbogen. So students, that is a mixture of oxygen and carbon dioxide, 95% of oxygen and 5% of oxygen. So if that mixture is used, carbogen is used, then the person affected can be treated. Now students, chemical properties of carbogen. So as I have told you, it is a combustible gas but not a support of combustion. Neutral to litmus, that means it will not turn blue litmus red or vice versa. That is, it will neither turn blue litmus red nor it will turn red litmus blue. And how does it react with the non-metals? Students, it reacts with the non-metals and it forms the carbon dioxide. Like if you see here, if it will react with the oxygen, suppose this is the oxygen is a non-metal, we everybody knows that. If carbon dioxide will react with oxygen, it will form carbon dioxide. Carbon monoxide combining with the oxygen will form carbon dioxide, and when it will react with the hydrogen, then it will form methyl alcohol in the presence of zinc oxide as a catalyst. And with the chlorine, it will form phosgene. Students, we have to remember this. The carbonyl chloride, which this carbon monoxide will react with chlorine, it will form carbonyl chloride, and the other name for carbonyl chloride is phosgene. They can ask you this in an exam. Reaction with the metals. So students, when this carbon monoxide reacts with the metals, then it forms their respective metallic carbonyls. Like suppose if here we are reacting nickel with carbon monoxide, so it will form the respective carbonyl, that is nickel carbonyl, and in this case iron carbonyl. Now students, carbon monoxide as a reducing agent. So students, when it combines with the certain oxides, metallic oxides, then it separates this metal and oxygen. That means suppose if we have zinc oxide and carbon monoxide is getting react with this, so it will liberate zinc. It will get zinc oxide it will decompose zinc oxide into zinc and carbon dioxide. That means it is carrying out the reduction. That means this oxygen is getting removed and this oxygen is getting combined with carbon monoxide, and ultimately carbon dioxide will form. Likewise, ferric oxide, then what will happen? Iron will remain. This oxygen atoms will go and combine here. That is, carbon dioxide will form. Now, what are the uses for carbon monoxide? Students, since it is a combustible gas and burns without giving smoke, so it is used as a fuel. And for the extraction of metals also, this carbon monoxide is used. Because when it is burnt when it is used in the furnaces, then what happens is that suppose in the extraction of iron from the hematite, which is its ore, what happens is that it combines with that hematite is Fe2O3, right? So students, what happens is that it takes the oxygen atoms from it and leaves iron separate, and this carbon monoxide gets combined with the oxygen atoms thus released, and then carbon dioxide is produced. The whole thing is explained in these two equations. If you can see, hematite plus carbon monoxide, then this iron will be left behind, and this carbon monoxide will get combined with the oxygen atoms, and here we will get carbon dioxide. And students, it is also used in the manufacturing of methanol, phosgene, etc. And more than 67% of the rural households in India still depend on the firewood and wood chips. Nearly 10% of the rural households still cook with cow dung cakes. This you might have also seen in your villages. And in certain states of India, as many as 95% of rural homes uses traditional fuels. And burning of such fuels produces carbon monoxide. And that is the reason almost 1 million deaths are reported annually in India every year. And LPG, therefore the government also encourages people to use LPG gas, which is less harmful in comparison to carbon monoxide, which is produced as a result of the domestic fuels which are used.